Hi, I'm Dave Baranek, a former F-14 Radar Intercept Officer, or RIO, and Top Gun instructor, and my call sign was Bio. Today we're going to have another F-14 episode, but we're going to go into the F-14's air-to-ground role. We're going to talk about LANTIRN. If you know anything about the F-14 Tomcat, you know that the LANTIRN pod was a major part of the F-14's capabilities during the later part of its career. I'm going to tell you a little bit about LANTIRN and answer a question that I've heard several times. Can LANTIRN be used with dumb bombs? First, let's get this out of the way. LANTIRN stands for, and I've got to read this, Low Altitude Navigation and Targeting Infrared for Night. That has to be one of the most contrived acronyms ever. But I'm going to cut them some slack because of the incredible capabilities of the system. LANTIRN was developed in the 1980s for the F-16 and the F-15E and was adapted in the 1990s for the F-14 Tomcat. This story is so interesting that it'll be the subject of a feature episode on my other podcast series, the F-14 Tomcast. In the F-14, the LANTIRN system consisted of a single pod that was always mounted on the right wing station, known as 8B. The RIO communicated with the pod through a hand control unit that had been developed for the A-12 program. The system provided a substantial increase in effectiveness for the F-14 once it took on the air-to-ground mission. In my own experience, I found that LANTIRN was easy to use. After a brief session with a simple tabletop simulator and one practice flight, I was qualified to go on LANTIRN missions. All of my experience with LANTIRN was during Operation Southern Watch missions. Southern Watch was when we enforced the no-fly zone over southern Iraq in the 1990s. We used the pod whether we were flying the counter-air missions or whether we were doing practice strikes. And at the end of every flight, we would look at our LANTIRN tapes. They showed a lot of information besides just video of the ground. In fact, as I recall, on my first LANTIRN mission, I had a switch in the wrong place. That showed up in the tape. After that, I don't think I made any mistakes, so I was good to go. The primary purpose of LANTIRN was to provide laser guidance for laser-guided bombs. This resulted in that pinpoint accuracy, the kind of direct bomb hits that make for such great videos that you see online. In addition, the LANTIRN pod provided very accurate navigation for the crew of an F-14A Tomcat. It was much more accurate than the 1960s era inertial navigation system found in the F-14A. Now to get to the question, can LANTIRN help with delivery of dumb bombs? To answer this, I asked a former RIO from the squadron that I commanded, VF-211, who had previously been an A-6 Intruder bombardier navigator. His very complete answer is what inspired me to make this video. To start with, dumb bombs need 4 things to maximize accuracy, and I'm going to be looking at my notes a little bit here. 1. An accurate model of the weapon's ballistics, so that an accurate release point can be calculated. In the F-14, this information came from the programming that we set with the weapons select thumb wheel to dial up the type of the freefall weapon. Here's the RIO's cockpit showing that switch. The next thing you need is a set of sensors that accurately measure air data, such as calibrated airspeed, temperature, and a lot more, as well as velocity, acceleration, and distance to the target. The third essential element is a computer to calculate the ballistic solution. Part of this includes calculation of winds, which it computes based on air data and aircraft ground track velocity from the INS, the inertial nav system, or GPS input. It uses this to cue the pilot where the release point is, or to make the weapon system release the weapon in the case of automatic releases. Finally, you need a pilot who precisely maneuvers the pipper to the target and presses the weapon release button at exactly the right time. The release cue takes into account the pilot reaction time, of course. An alternative is computer-initiated release. Comparing release initiated by the pilot or by the computer is always more accurate. LANTIRN used a computer-initiated release after the pilot enabled it. So, it comes down to which sensors provide the most accurate information for the computer to calculate the ballistic release solution. The ASN92 INS, or inertial nav system, in the F-14A had an inherent drift since it used a mechanical gyroscope. It could not match the accuracy of the GPS in the LANTIRN with its laser-measured distance to the target. So LANTIRN wins the system accuracy also. The problem is the F-14's LANTIRN system did not contain the ballistics calculations for freefall bombs, only for the GBU series of precision weapons. That makes the question academic. But to pursue it to an answer, the ballistics of freefall weapons are so much different from the GBU series weapons that a LANTIRN solution would not be relevant for freefall bombs. Now you know a little more about LANTIRN and air-to-ground weapons. Keep watching for more videos with my personal aviation stories. You can also check out my website, www.topgunbio.com, for more pictures and stories. Cleared and switching.